Hey everyone. In this video, we're going to be talking about disaccharides. And so in order to do that, we will need to discuss glycosidic bonds. And then we're going to look at three specific examples of some common disaccharides. And the learning objective for this video is you should be able to identify the type of glycosidic bond in a given disaccharide. So what are disaccharides? As the name implies, di means that it is two sugars connected together. And the reaction that connects two sugars is a dehydration reaction, meaning when the two sugars are linked together, there's a loss of a water molecule. And so we'll look at the formation of three specific disaccharides today. Maltose, which is formed from two glucoses, lactose, which is formed from glucose and galactose, and sucrose, which is formed from glucose and fructose. So let's take a step back and talk about acetal functional groups. So hemiacetals can react with alcohols to form an acetal functional group and kick out a water molecule. Now, an acetal is basically two ethers connected to the same carbon, but they have special reactions that regular ethers don't. And so we refer to this as an acetal. So previously we looked at how sugars can form a ring as a cyclic hemiacetal. And now we're going to look at how the hemiacetal reacts with another alcohol to form the acetal. This can happen between sugars where the OH group of one sugar reacts with the hemiacetal of another sugar, and this creates the full acetal functional group. Now, when you have an acetal formed between two sugars, it's known as a glycosidic linkage. And we describe the type of glycosidic linkage depending on which carbons are involved in the bond. So in this case, it's carbon 1 connecting to carbon 4 through the glycosidic bond. And so we would say that this is a 1,4 glycosidic linkage. Now, we can further specify depending on whether we're alpha or beta. So recall that the anomeric carbon can either have the OH pointed down or up. And so we refer to that as alpha or beta. And so if that anomeric carbon is part of a glycosidic linkage, we can say that it's an alpha glycosidic bond or a beta glycosidic bond. And that determines the bond angle between the two sugars. You can see how these are, more linear or more bent depending on the angle of that glycosidic bond. So alpha 1,4 versus a beta 1,4. Now, glycosidic bonds can be broken through hydrolysis. So the formation of the glycosidic bond kicks out a water, and if you put the water back in, you can cut the glycosidic bond and go back to the two OHs. Now let's look at the three specific disaccharides. So maltose, also known as malt sugar, is composed of two glucose molecules. And so the two glucoses are going to be linked by an alpha 1,4 glycosidic bond. So carbon number 1 here is in the alpha orientation, and it's going to connect to carbon 4. Highlighted here in pink is where the water molecule is coming from. And so in the disaccharide, you can see this alpha 1,4 glycosidic bond. Now, lactose is the sugar in milk, and it's composed of a galactose and a glucose linked together. But this linkage is as a beta 1,4. And so you can see that the OH on carbon 1 is up, so it's in a beta orientation. And so when it links together, it's a beta 1,4 glycosidic bond. Highlighted in pink here is where the water comes from. So lactose is beta 1,4 between galactose and glucose. Now, sucrose, known as table sugar, this is the type of sugar you buy at the grocery store, is composed of a glucose and a fructose. Now, the carbon number 1 of the glucose is in the alpha orientation, but we're connecting to carbon 2 of the fructose, which is also the anomeric carbon. And this one is in a beta orientation. And so because the bond is between both anomeric carbons, we have to specify whether each one is alpha or beta. And so it's alpha at carbon 1, beta at carbon 2. So we say it's an alpha beta 1,2 glycosidic bond. And so that type of glycosidic bond is unique to sucrose, alpha beta 1,2 glycosidic bond. Now, because both anomeric carbons are linked together, these rings are essentially stuck in the ring form. They can't reopen. So a single sugar can open and close, and it can oxidize when it's in the open form. Sucrose here has the two rings fused. They cannot open. They're permanently stuck closed. And so sucrose will not react with Benedict's reagent, and it is a non-reducing sugar. So it can't be oxidized. So here's a better image showing you the two individual sugars coming together. And so you can see carbon 1 is alpha, carbon 2 is beta, and then we're going to link those together as the alpha beta 1,2 bond. All right, let's do a study check. Melibiose, shown below, is a disaccharide that's 30 times sweeter than sucrose. What type of glycosidic bond links the two monosaccharides? So the first thing we want to do is number the carbons because we need to know which carbons are connecting together. And so this is going to be carbon 1, 2, 3, 4, 5, and 6. And on the second ring, 1, 2, 3, 4, 5, and 6. And so we can see here that it's carbon 1 connecting to carbon 6. Now, carbon 1 is the anomeric position. And so we need to decide if this is in the alpha or beta conformation. And we can see that the oxygen is coming in a downward orientation. And so we know that down is alpha. And so we would say that this is an alpha 1,6 glycosidic bond. So once again, to determine the type of glycosidic bond, number the carbons in each ring, figure out which numbered carbons are connecting together. In this case, it was carbon 1 to carbon 6. And for carbon number 1, because that's the anomeric position, we have to specify whether it's alpha or beta. And in this case, it was down, which was alpha. So it's an alpha 1,6 glycosidic bond. And the three sugars, the three disaccharides that we learned about were maltose, which is made of two glucoses in an alpha 1,4 orientation. We learned about lactose, which is a beta 1,4 bond between galactose and glucose. And then we learned about sucrose, which is an alpha beta 1,2 glycosidic bond between glucose and fructose. So those are the three common disaccharides and the types of glycosidic bonds that connect them together. Thanks for watching, and I'll see you in the last video.